All right, I think we are live. Um, all right. So, we are back again after yesterday and the day before. We started to look at FizzBee. It's a formal specification modeling language. We started looking at that. And yesterday we started, well, I attempted the exercise 1, and for a moment there I thought I solved it, but then I looked at the solution, I picked at the solution, and I realized that there was a safety property, or I guess an invariant that I missed. So I got this one, but I missed this one. And so that basically made my solution, right, not a solution. And so I figured, the plan was that today we'll resolve that issue. So part of the issue with my solution from yesterday was that, again, I missed this invariant here, but yesterday and even now, even though I just started looking, I'm not so sure where the invariant itself comes from. And I think that's problem number 1. Problem number 2 is I think I still need to I guess deepen my understanding of the use of the fairness modifiers or annotators. I don't know what to call them. I think it's modifiers. So we have the weak fairness and the strong fairness, and from what I recall, with weak fairness, it's the idea that you are suggesting that given that when an action will be what's the word? Infinitely enabled, and as a result of that, it should be infinitely like ran. Is that? That's not the most clear way to put it, but I think there was the example of a process where if a process is enabled, which would, kind of mean that it's ready to accept work and do work, that as long as the process is ready to do work, it should receive work, right? So that will be weak fairness. Strong fairness will be if a process is off and on, like ready and not ready, ready and not ready, it should receive work at some point. So again, strong fairness, as defined earlier, strong fairness is defined as if an action is enabled infinitely often, it will be executed infinitely often. So an action that is enabled at some point should get the chance to be also executed, regardless of whether or not it's toggling between enabled or disabled. With a weak one, it's tighter, and I guess in that sense, well, it's less liberal. I guess you can put it that way. Like it's, I guess it's more relaxed, hence weak, which is, well, actually, is it? Would you say that that's more relaxed? I think it's a case of the precondition. Actually, the precondition for strong fairness sounds like it's the more relaxed one because you can allow the action to be uh, to oscillate, or I guess bifurcate between being enabled and disabled, and still uh, ensure that it gets ran. But for weakness, I mean, to me at least, it sounds like that's the less. That's the more. The precondition is actually stronger in this case. That's interesting. Because, I mean, that goes against the whole weak fairness in the name, right? Weak. But to me, it sounds like, I don't know, when I read it, the way I'm understanding it, the precondition is stronger than the one for strong fairness. Because with strong fairness, you're allowing things to be either disabled or enabled as a precondition. And by things, I mean, actions. Which means that fundamentally you're allowing for more, you are increasing the state space, but you are also asking for the same outcome, right? So with weakness, the state space is reduced. So I don't know. I guess maybe it's just the way I'm understanding it. Maybe one would say that actually it's the reverse, as in it matches the qualifier, the weak qualifier. Yeah, and the key difference is continuous versus intermittent enablement. First statement: the action must remain enabled without gaps. So that's the weakness one. And for the second one, the action just needs to keep going back to enable state. Yeah. The second one also covers cases where the action toggles between enable and disabled states infinitely. Okay, so that's fairness. I think before that we had the require word, which is really for guards, which dictates when an action is enabled or disabled. So going back to the original problem, the first statement is the system starts in an idle state, and when there is work, it gets to do work. Ooh, that's hot. That's hot. Okay, so the system starts at idle. When there's work, it gets to do work. But how do we know that there is work? I guess that's the part that, okay, let me ask ChatGPT, well, not Chat, Claude. In statement, I don't know why, but today my typing has been shit. In statement 1, how do we, do I have AI tracking on this? Yeah, I think so. I don't like it when I'm streaming and it's moving all around. Okay, so in statement 1, how do we represent the fact that when there is work, it gets work, right? What does it mean when there is work? Like, what's the flag that tells you that there is work? I guess we need a variable for that. Because so far we have, for the statuses, we have idle, working, fail, and shut down. So how do we know that something is ready to work? I mean, it's just a random action. Because my initial, what I've implemented yesterday, as you can see, it's a matter of when the system is in idle, either it shuts down because there's no work to do, or the do work one gets triggered, right? And I think the original thing that I did was I encoded that binary choice as a one-off, because that's a construct of the language. Actually, let me try that just for shits and giggles. I think it was, I think I did, I'm just gonna call it from idle, and I'm gonna say, I think it's require status idle, and then you can do that, and then you can do one off. Shoot, I think I forgot the notation for one off. One off. Okay, so it's a block. Okay. Can I, is it one of those where I can add it as a modifier at the action level or not? Okay. So I think it's status is working, or status is idle. No, not idle, shut down. And so I'm gonna remove this. So when a system is idle, we either go to working or we shut down. But this action would only be enabled when status is idle. And in the definition, it does say that push down the system can fail. A failed system will be fixed eventually. On fixing, it gets to idle state. A shutdown will be restored eventually. So here, wait. The shutdown will be restarted eventually, which means we go back to idle. A failed system will be fixed eventually. On fixing, it gets to. So I think I wrapped these two up together here. Maybe I should rename this to resume. Work or sleep. Yeah, I like that. Work or sleep. And this one is saying if the status is equal to fail or status equal to shut down, then we put it in idle. Now I think this should have like I need to start thinking in terms of the fairness here. We want to eventually reach we want status to eventually be working, and we also want shutdown. Actually, why can't these two be combined? I'm actually not sure why. I know that this part I noticed it in the solution, but that's the only part that I cared to include in my own solution. I'm still not sure where that invariant comes from. Oh, did I ask? It gets work. Okay. I never pressed enter. Okay, so it's basically what I said. At any time. Non-determinism captures all scenarios. We'll explore the system staying idle forever if not forced by fairness. The system immediately getting work. The system getting work after being idle for various amount of time. Can a system transition from idle to working? What happens after it starts working? Can a system transition? No, we're not doing that. Okay, we're not doing a worky thing. Skip it simple. Can a system transition from idle to working? That's a good question. As things stand, there's no fairness being applied here, so yes, we'll definitely not be compliant with these variants. in that particular case. So we need to force fairness in some of these actions. Well, our target is that we want the status to be eventually working and eventually shut down. Well, this so the fairness actually, okay, it's a weak fairness, which means it's requiring that the status is that it's enabled continuously, because it's a weak fairness. But wouldn't that mean that yeah, actually I'm not so sure that I understand that part. So by adding the fairness here, I'm saying that I want this to be enabled, this action to be enabled without any toggling between enabled and disabled. But then doesn't that mean that I'm also requiring the status to always be in idle? Let me ask. So I wrote this. Does this weak fairness mean that I'm demanding that the action always be enabled? In that case, does that mean I'm also requiring the system but actually that does not also make a whole lot of sense, because even if it gets enabled once and then you set a status to working or shut down, then that same action becomes disabled, right? Does that mean I'm also requiring the system to keep the status to idle? I'm fuzzy on fairness and the non-determinism aspects of things. Pondering. Alright, excellent question. You are not demanding that the action always be enabled. Let me clarify how weak fairness works with your example. What weak fairness actually means. If an action is continuously enabled without interruption, it must eventually be taken. This does not mean the action must always be enabled. The system must keep the status idle, or the action must be taken repeatedly. Okay. Alright. The fairness here means if the system stays in idle forever, if the system says then this action must eventually fire. Okay. Once it fires, status changes to working on disabling the action. Uh, okay. The key insight: fair weakness prevents the system from staying idle forever. It's the opposite of what you were worried about. Without fairness, the system could stay idle forever, never taking any action. With fairness, if idle, the system must eventually transition out. Um, if the action is no, if the status is in idle forever, oh, so it's not the action's enablement itself. Wait, no. I think I get it, but I'm also like, it's not crystal clear. If the system stays in idle forever, because that's a choice that it can make, right? As part of running the model. Still a little bit there that is missing. Like I don't like absolutely get it right off the bat. I mean, it's one of those things probably where you just have to keep doing it, keep trying things until you completely internalize it. Okay, so assuming that, you know, that we fully understand this, right, with the fairness. So we are forcing the issue here and saying that if the status is continuously idle, then at some point we want the status to either be working or shut down, which I guess would, excuse me, will satisfy this, right? Well, one, but not necessarily the other. Because there is a universe where one of always picks one of these and not the second one, in which case one of these will be violated. At least just looking at these two for now. So one thing that we know is that we start off with idle. If none of these actions run after a while, at some point this action will run because of fairness. Um, well, let's say that we ignore this part for now, right? And we go from idle, and we can either go to fail or resume, but then none of these will apply. Because you can't transition the state from idle to something else via fail or resume. Okay, so let's say, let's say that you transition, you are in working. You may then go to fail. The system can fail anytime it's on, which means when it's not shut down. Okay, so from fail, the fail system will be fixed eventually. The shutdown system will be restarted eventually. I think you also want fairness here. But I don't know if you want strong or weak fairness. So if we apply the same idea here, we're saying if the machine decided to be in the fail state indefinitely, it will be forced to actually switch to idle. Same thing for shutdown. If the action is, if we get into a state where we go into shutdown, progress will still need to be made, which means, at some point, progress will be forced out of either this state or this state. I'm trying to decide if I need a strong fairness here. I have a feeling that I do. Just because wait, so what does strong fairness mean again? It's we want the thing to be continuously enabled and disabled. Let me ask Claude if I got this correct. So I'm adding this part now. Does it mean that if the system toggles between each of those flags or states, fail and shut down. Then this action must eventually fire. Okay. With your code, this means that it keeps visiting fail or shut down states repeatedly, even if interrupted by other states in between. The resume action must eventually fire. Consider this sequence fail, working, fail, working, fail, working, fail, working. Resume is enabled when in fail. Resume is disabled when in working. Back in this cycle. Okay. But also, but the thing is, I don't think you're supposed to be able to go from fail to working, by the way. Action must be continuously enabled. If status stays at fail forever, resume must fire. But if status toggles fail, working fail. Yeah, but again, I don't know if this is a particularly good sequence here. Because going from failing to working is not I don't think that's a valid transition of the system. Oh, wait a minute. Jesus. Oh, never mind. I thought my screen was frozen and none of the things that I'm showing were showing. But I was just glancing at a still picture or screenshot from yesterday. Action must be enabled even with interruptions between. Perfect for your resume action since system might bounce between states. Alright, well, let's so I have fairness here. So when this is enabled, continuously, which means the system chooses to get stuck in this status, then we eventually switch to working or shut down. And this tells us that when a system chooses to flip between fail or shut down and another status continuously, eventually we must go to idle. That's my understanding. Now for this one, I don't think we need any fairness. Right? So the weak fairness here will say if the system chooses to not be shut down indefinitely, then we must switch to fail, which I don't think is a thing that you practically want in such a system. And it says a system can fail, doesn't mean that it has to. So oh, wait a minute. What if wait, so what the only way that okay. Interesting. I guess a system can repeatedly fail. So let's say a system is working, it goes to fail, but then it can just stay at fail. Well, okay. In this particular case, because there's no fairness, again, if a system chooses to not be shut down continuously, then there's no fairness. There's nothing, like we're not saying that it will be unfair to transition to fail, which makes sense in practical terms. Like if your system is not shut down and it's either idle or working, there's no reason for you to expect a failure just because. Now, with the strong fairness case, here we're saying the system may choose to go between not being shut down and being shut down. And that eventually you should fail because of that. Again, yeah, I don't think that's practical. All right, just gonna submit this. It's probably wrong. Maybe. Yeah, okay. Seems like liveness check failed. Wait, why? Let me think about this for a minute. In what way can we ensure that we never eventually shut down? Well, it's one off. Right? It's one off, so the system can choose to always go with shutdown, but not. Okay, which one is failing? Yeah. Uh, Wait. Okay, yeah, it's just this one that's failing. For a moment there, I thought it was both. Um, so the idea here, seeing this, tells us that we never actually enter the shutdown state. And this will be the case if the system manages to go into working. Like, what happens if it goes into working and then it just stays there, continuously working? There's nothing that says that like there's nothing in here that forces a switch from working to not working. Yeah, actually, that's a pretty clear cut case of invariance check. Like, literally, you go from status idle, right? You choose working, and then you just stay there. Like, there's nothing forcing a non-working status. Don't want to add a fairness there, but actually, let's just see if it even passes. Nope, still does not. This one I'm just curious. So strong here means transition between that and shut down. Nope, still fails. Zapapai. Alright. Let's see. So you're in idle, then you fail. Okay, so from idle you go to fail. And then you resume. Wait, but I thought this would I mean, if you go to idle and you stay enabled, this stays enabled, eventually, aren't you gonna just get to one of these? So from side to side, you can fail and fail and fail and fail and fail and fail. But then eventually you resume. Whew. Go to working, you fail. Excuse me. So either you fail or you shut down, but then eventually you come back to idle. Oh. Okay, so this one is you go from idle to fail. You keep failing, and eventually you resume. You resume back to idle. Oh wow! In this one, you never even go to working or shut down. So the system that's failing eventually goes to idle, which is what the step 4 here does. But you never went to working. But I guess what I don't understand is once you've is it a matter of also when the model stops running? Oh no, because I guess what is the fairness of resume strong? I mean, I guess this can just keep happening in a loop, right? But wouldn't that go against the fairness here? Which says that, oh, but this requires continuous enablement, which this bypasses, right? Because this is not continuous enablement. Like this is not continuously idle. It's constantly shifting between idle and fail, idle and fail, idle and fail. In fact, it does idle, fail, 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 idle. This particular error will be solved by strong here, I believe. This, but I'm not saying that that's the solution for the whole thing, but at least this particular execution path, which basically can loop on itself forever, and so the invariants are never satisfied. That particular one should be solved by this. But let's say that that's true. Alright. You still have the problem of it choosing to add another possible execution, right? From idle to fail. Instead of idle to fail, it will be idle to. You can just choose one of them and never hit the other one. But okay, let's say that that's true. Let's say it only hits working and it never hits shutdown. Then this will be satisfied, right? But can we also satisfy shutdown at that point? Not really, because once you enter working, you can literally just stay there. Because there's no fairness here. Yeah. So you will satisfy one, the working one, but not the shutdown one. So I guess this is the part where maybe the one-off thing is not great, or it's not a good thing to include. Maybe I do need to break this down into two different actions. Let me ask. The thing is, I don't want to copy the whole thing and paste it in there, so that it just kind of gives me a bunch of, like, it tries to fix the whole thing. Oh wait, no, okay, never mind. And it's fun. It's interesting because the only choose one of actually only works with this, with working. If it continuously only chooses this as part of the one off, then it will be forced to go to idle at some point. But then from idle again, it will just be forced again to shut down. Not working, but to shut down. And yeah. Wait, did I already put that in here? Oh no, that was the other one. Man, this is why they say formal. formal modeling can be a bit of a doozy, because now you have to account for, or at least make non-determinism like a first-class citizen of your system. What do I want to ask? Am I right in assuming that the model or the system can choose to always pick status equals working for the one-off? Yeah. Yeah. Yeah, it sounds like I'm gonna need to do this. Okay, so I do need to break this up. But now, does that actually solve the problem? So this is saying if the system continuously enables idle, then for the sake of fairness, it has to transition to working at some point. Like if the system chooses to get stuck in idle, it will be forced to either go to working or shut down. If it goes to working, but then if it goes to working, it can just get stuck there, right? Can a system go from idle to idle? Because then I can just say if status is not equal to working, so it's either fail, shut down, what's the other one? Wait, isn't it? Or idle, even. It can just go back to idle. So if the system chooses not to get stuck at working, right? And it switches between working and not working, whatever. then eventually it needs to go to idle. Let's see. Which one of these invariants will fail in this case? So I can go to idle and then just decide to stay there. But then I will be forced to go to either working or shut down. So let's say I do that. Can I just decide to stay shut down? No, because I will be forced back to idle. So I can just decide to stay on working at this point. What about shutdown? If I try to squat on idle, I can't. I eventually need to yield to shutdown or working. Well, let's assume that I always pick shutdown. Then it shut down. Yeah, what happened? Well, this, at least this will be satisfied. But then is there anything that's forcing me to go from shutdown to idle? Yeah, this here. Alright, well, I have a good feeling about this, but then again, I said that a million times now, so. And I'm wrong. Again. Alright, so idle. I decided to go to fail. Gosh, I keep forgetting about the fail. Oh, fudge. Okay, so you go to fail. Is there anything to switch you from fail? I mean, there is. No, yeah, it should be forced back to idle. No? Yeah, it should be forced back to idle. Eventually. But then you just squat on idle? Oh no, because then you can go back. Oh, fuck. I keep forgetting that you can't just think. You also have to kind of isolate particular pairs of actions depending on the combination of fairness all over the place. Yeah, because then you can loop back around. Because now you're not squatting on the idle state, which means that the fairness here does not apply. finance here does not apply, so you go back, you go into this loop, and you never get to shut down or work. Here's the thing. In my head is telling me, oh, just put fair strong everywhere and you'll be fine. And I feel like that still won't do it. Right. Well, actually, this particular run will not work because at least it will be solved for this particular run. Because this idle can go back to fail, which by the way doesn't make any sense. Oh well, actually no. Fail. So idle, fail, idle, fail, idle, fail, idle, fail. So idle, fail, fail. Well, eventually you'll have to go into working. Okay, let's say you did that. Can you just squat on the working status? I don't see why not. Like once you get to working here, there's nothing forcing you back to well, there's this action here which you can take. There's no fairness to it, but it's still an action that can be taken. So you can go back to, you can go to fail, and you can just loop on yourself to fail, 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 fail. But then you'll be forced back to idle. Which I think means that you will also be forced to no, there's nothing for, I don't think there's anything forcing you to go to shutdown. Man, this is kicking my butt. And it's the very first exercise in the book. Jesus. It's the fairness that's kind of messing with me. There's that fucking starter. Yeah, I think this is... I don't know. I think I may have reached the diminishing return threshold where I might be better off working through a solution than keep hitting the wall. But I think the main issue for me right now is that I'm not fully internalizing the non-determinism and how fairness plays into it. And the fact that I think the more actions and state options you have, I think the harder it is to fully grok, at least for me. Maybe somebody out there was able to one shot this, I wouldn't be surprised. There are always those kind of people, and there are always people like me who are not. We do okay in life. Yeah. Okay. So what do I want to ask? I don't want it to just give me the answer. I want it to give me a diagnosis. So give me a diagnosis of what's wrong here. Approach this from a Socratic is that how you spell it? No, Socratic. No, okay. Just be Socratic with the aim of helping me figure out what's wrong and what is the path to a solution. Okay. Doesn't feel great, I'm not gonna lie. Very first exercise, and I mean on the surface it looks pretty like straightforward, I think. Okay, trace a cycle. Starting from say, can you trace a path that gets back to idle? What are the possible cycles in your system? Seriously? I'm working over here. I'm working, Monica. Can you stop? Nobody wants to hear that. Please don't scratch me. And don't break my stuff either. Okay. Starting from status idle. Can you trace a path that gets back to idle? I mean, yeah, we saw one earlier. When you have idle, you go to fail. Then you go to fail again and fail, fail, fail. Eventually, can you not? Don't. You're not helping, Monica. I'm not doing so good over here. I thought I would have this figured out by now. Okay, so you go fail, or even once, or whatever. Oh my God. And then you get forced into idle, and then you go back to fail. You're not helping, Monica. You're not. Like, please stop. Okay. Idle. What am I saying? So I think my answer to question 1 will be, an example will be idle. You go from idle to well, you can stay stuck at idle due to the strong fairness here and here. Seriously? So you can either go to actually any one of these will do, because you're not shut down, so you can go to fail. You are not working, so you can just go back to idle. What are the possible cycles? I don't know. Aren't there like many? But you just end up right back at idle. Okay, the competing actions. Look at start work and shut down. Where's start work? Oh, okay. Have strong fairness. When a system reaches idle, what happens with these two competing fairness requirements? Can both fairness constraints be satisfied? Interesting. Okay. When the system reaches idle, what happens when these two competing fairness requirements? Is it trying to hint at the fact that well, no, they both have to be picked at some point, right? Isn't that the point of the strong fairness? Like, if you do idle, then you do working, then you do fail, and you do fail. You can just squat at this level here, um, you'll be forced to go to idle again because of this. At least in my head, that's what I'm telling myself. This is based on my not so very sharp on this fully grokked fairness, the dynamics of the fairness, or the non-determinism of the fairness. Shoot, I lost my train of thought. I think it was fail. Like the way the system is correctly written, you wouldn't be able to stay stuck at fail. You'll eventually go back to idle, but then can't you just restart the same cycle, which is what is being pointed out? By question number 2, you can restart the same cycle. You can go back to idle and just do exactly what you just did the first time, and one of these will not be satisfied, because you can literally just pick. Well, and I guess that's the part where I'm not so sure. Can you indefinitely choose the same path in that cycle that we just talked about, which is idle, idle working, right? Idle working, and then you can either go to either back to idle or fail. If you go to fail, you can keep failing until you cannot, right? Yeah, until you have to go back to idle. Or you can go from working to I was gonna say resume, but that's not the case. Can you ever go directly from working to shut down? I don't think so. Is that something that I just realized? I think so. I don't think you can go from working to shut down ever. Or at least directly. And if that's the case, the model can conveniently also arrange that we never see the shutdown path going from. I think it comes down to that, right? The fact that the model can choose one of these and never deviate from that. But then that puts into question my understanding of the fairness. Because then it would be idle working, idle, working, fail, 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 idle. Yeah, but then with the strong thing, wouldn't you be forced to do this at some point? I thought that was the point of the strong fairness, because you're enabling between transition between idle and not idle. Or does it have to be a direct transition to work? Actually, that doesn't make sense. So idle, working, fail, idle. And then you keep going in that loop. Idle, working, you can do idle, working, working, fail, 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 fail. How many times you want. But then eventually you'll go to idle. And then you can just restart the cycle. I guess what this breaks down for me is the fact that you can actually make that choice to always go back to this working state instead of being forced to also choose this path. And I think that exposes the limited understanding that I have of how fairness weaves into the non-determinism. It's asking, can both be satisfied? If you switch, I mean, this is saying if you're switching, if you enable status idle infinitely, at some point you need to run this, but this is saying the same thing. Excuse me. I don't see how these two cannot be satisfied though. It's just a matter of having to pick one of them, right? I mean, if you pick one of them, you can just kind of satisfy this, right? But does that preclude satisfying this? I think that's what Claude is implying, but that's not my understanding of fairness or strong fairness. Okay, you are asserting the system will always eventually be in shutdown. Think about what always eventually means. It's not just reaching the state once, but reaching it infinitely often. Oh. It's not just reaching a state once, but reaching infinitely often. Oh. I guess I did miss that part of the fairness. um, definition. It's not enough for it to just happen once. It needs to happen infinitely often. And I think the hint here is that both cannot be satisfied at the same time, which again, at face value, that sounds wrong. Because, I mean, you just pick one. Like, whenever you are idle, like this is incredibly contrived, but if you're idle, then you can have a run where you pick this one, start work, and then the next one you do shut down. I guess like my thinking was that even if the model was trying to choose to choose this particular one infinitely many times, it will be forced not to, or to also pick this infinitely many times. Which, I mean, theoretically should be possible because, I mean, infinity is infinity, right? Okay. Once the system is in shutdown state, trace what happens next. Where can it go? Can it ever reach working again? Alright, once the system is in shutdown state, alright, you can go to idle, right? So let's say we did idle, then we did shutdown. Then I guess we do idle. And then we can repeat that loop again. Shut down, idle, and then again in the same loop. Can we ever get to working is a specific question. So once you're in this state, shut down. Oh, but this is not. No, okay, never mind. Well, you can't get stuck at shut down. You'll have to transition to idle because of this. At least that's my understanding again of this due to the strong fairness. If you enable shutdown infinitely often, then you'll be forced to go to idle at some point, or infinitely often as well. And then you will go to fail, or you can go to fail. and then go back to idle, and then go back to fail, and then idle, and then fail, and then idle, and then fail. Can you get out of being in that particular loop? Yes, because eventually once you get, at some point one of these needs to be picked, which can also just be shut down again, and so you restart the loop again without this ever being satisfied. It's not that I'm not thinking through this, it's just I'm responding to Claude here. Take a moment to think through this. It's that I guess the sticking point for me is I don't understand why fundamentally these two, but it's not clear to me why these two cannot be satisfied. Again, I'm assuming that that's the core issue here. Alright, lay it on me. I'm gonna lose this battle, but that's just the beginning of the war. Yeah, the fairness is well, the fairness and I guess the non-determinism is kicking my ass. A shutdown trap. Once your system enters shutdown, yeah, I mean, that's what we just went through and explained to ourselves. You can just go. But again, that's the part where I don't understand. Why is it not forced to go into to pick start work? Because you're enabling and disabling idle infinitely often, right? Shutdown's fairness is satisfied. Where is it? Okay, yeah, it fires. And idle. Yeah, that too I get. Idle's fairness, or resume fairness. Fires. Okay. But Star one never needs to fire. That's what I don't understand. Why? I think we've been through this loop ourselves already. Fairness is satisfied, can fire. No fairness needed. Strong fairness satisfied by Chandler. Even though both sides have strong fairness and both enable when idle. Okay, I think I'm about to have a reveal for why. Strong fairness only says each action must eventually fire. Oh. Wait. What? Okay, but it's the strong fairness. Okay, so when you have, oh, okay, I think that's actually a critical point. If you have multiple strong fairness for the same predicate, only one of them is required to fire. That's actually, I mean, that will explain. I mean, that's the answer um, to my question, which is, why was the system not forced to fire both? But yeah, it just needs one of them because they have the same predicate. Like the fairness is, you can have multiple fairness. Um, for the same um, for the same state predicate. Well, I guess for the same state, but only one of them will be picked. Pick one letter. No, I need both apparently. I mean, I had a solution that worked with just one, which was the one that is actually stated. Um, Actually, did I ask? Where does the? I can't believe I didn't ask that actually. Um, will be working eventually. So yesterday I had a solution that worked with this specific fairness, but then I glanced, like I said at the beginning, I glanced at what the solution was to compare mine to them, and I realized that actually in their solution they're using two fairness. Um, this one is the one that they added, or they have that I didn't have. Okay, so false alternation. Um, Forcing alternation is what I need, I guess. Also, I don't like the fact that I have so many strong fairness things. How would you force alternation here? Mm-mm-mm-mm. Would it be um, when idle? Okay, so I can't actually remove that here. Um, I can't make this shut down because that doesn't make sense. You have to transition to idle first. Um, um, if it's idle, um, mm, so if I'm in fail, um, or status equals fail. So in this case, it will force a shutdown at some point. It won't be able to only pick working, right? And in here, idle shutdown, idle shutdown. Um, how do we force it to go to so I mean the change that I just made will solve this issue here. It will force it to also pick um, it will force it to also pick oh, but it's all. It just needs one of these to be true though. Like this is enabled as long as status is idle. So I don't know, I don't think that change actually makes a difference. What can we shut down faces? I mean, right now I think it's just fail. Like there's no going from working to shut down. So idle shut down. Wait, what am I doing again? My brain is starting to wanna go to sleep. But I don't wanna come back to this again later. I wanna move on. Between working and shutdown. bugging right now. Real hard. Keep forgetting exactly. Okay, so alternate between working and shutdown phases. So the original issue is that only one gets picked, and so we need to force the issue. So a shutdown system will be restarted eventually. Wait a minute. Shutdown system will be restarted eventually. It's not equal to working. Well, that's what we have here, right? To fail. When you go to fail, can you actually transition from fail to back to working? Oh no. Yeah, so yeah, fail has to go back to idle, which is handled by this. So I have two choices. I can ask God to give me a solution. Or in fact, yeah, I'll do that. And I actually want to compare that to the one from the book, and one, see if they're the same. And two, how does it compare to mine? Alright. Yeah, I think I really lost this battle. Doesn't feel great. is this? There. Okay, that was weird. No, that's not. Okay, let's see. Yeah, I was eventually okay. So start. So you start work from idle to working. This is basically the same as this, right? Finish if working, go to idle. Oh, I think that's. Wait, is that what I'm missing? Because I got this one. I got the resume, which I did them both as one thing. For shutdown, oh, status not in working, I'll fail. Okay. Looking back, I am questioning why I thought that you can only shut down when idle. What is this? Oh. Because of this. Are there any other? So there's working failed. Right? Working failed idle. What's the difference between what I wrote and what I wrote? Let me ask. Just, sanity check things here. Versus do they not mean the same thing? Do that. I'm gonna change this to just fail. Okay. So how do they solve that though? With this here, that's how they solve that part. The part about if you get stuck in here, then you eventually transition to idle. Um, okay. I'm actually curious. Is it weird? This took me forever and I still didn't quite figure this out. That is, the above is the solution from the manual compared to what I posted earlier, which was mine. But yeah, okay, so what did I miss? I don't know how true this is, by the way. It's probably just saying that to make me feel good about myself. I don't know. I think you're just saying nice things. I think I'm gonna ask I'm gonna ask some people. You can start a manual ad that makes everything work. Your approach. Idle, working, idle. Yeah, that part I got. Like, once you're in working, I didn't plan for the fact that I think conceptually in my solution, there's no concept of just ending work without it being a failure or a shutdown. There was no like the work just ends. It was either a shutdown or a failure. I mean, hindsight is 2020. I can say that now, but in the moment, somehow I missed that. I was so lost in the whole fairness thing that I didn't pick up on that basic idea. And what's his name? Claude. What's its name? Claude was probably trying to hint at that in one of our earlier in one of the earlier messages, and I didn't pick up on it. That is actually quite a glaring omission. The fact that there's no going from working to idle. Well, I think I had this one. Like going from shutdown to idle. I had something for that. Which was this. Right? If it's not working, go to idle. The genius move, the finish action. Yeah, I did miss this critical part actually. That's a pretty that's that's a blunder. I'm not gonna lie. I should have caught that very early on. I think this is a lesson in uh, you get so caught up in trying to uh, maybe figure out some of the complexity from non-determinism or whatever that maybe you forget an obvious thing that you should be uh, implementing. From idle, fairness forces both start and shut down to eventually fire. Why, this is how you were thinking. Revision system works until it fails. Uh, yeah. System can shut down when idle. System recovers from failure. But the manual adds a sub concept work can complete successfully and return to idle, which, yeah, I think that's something I should have inferred. It doesn't say it explicitly here, but that's something that I probably should have inferred. Um, mm, 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 mm. The manual's version. This is actually helping maintain fairness. You were really close. Yeah, you're just saying that. I'm sure there's an experienced or a quote unquote cracked developer out there who, if they saw me struggle on this, would be like, yeesh, I can do this in my sleep. Is it generally hard? I don't know. I don't know. I don't necessarily believe that. At least it doesn't seem that way just by reading it. I guess it's the implicit stuff or the unknown unknowns. Well, I don't think there was really an unknown really here. It's more sort of inferring things. But then again, you also have to be careful with that, right? Because you may choose to infer some things that turn out not to be true or not to be contextually um, just true or relevant or even assumable. Is that a word? Something that can be assumed. Anyway, so first exercise, that was a failure. I mean, I did try in my defense. Maybe I didn't try harder. Alright, so we did the getting started. We'll get into more stuff. We have examples. Maybe I should just do that, right? Just skip to the examples. That will be next week, by the way. Yeah, but I think, I don't know. Like, what will I lose by not going through each one of these and just skipping to the examples? Because I feel like I just need more time to get in the groove of both the language itself, but also the mindset. Oh, they have annotations. Okay. Well, we'll see. I probably won't be doing. If I do stream, I don't think it'll be for FizzBee tomorrow. It'll be to do something else, but I'll be back on that next Monday, next week. And I guess by then I will be decided on whether to keep going with the tutorials or to just jump right into reading the examples and then have Claude here help me with figuring things out as I read through the examples. Yeah, but I think I don't know if I like that approach, because ultimately, even if I keep struggling with the tutorials, at least actually actively engaged in the process. With the examples, it's mostly just reading it, which I think will be more appropriate once you set up a baseline. Let me see, is there an exercise? Yeah, okay. All right, well, wow, that was a long one. 2 hours and almost 30 minutes. All right, well, this is where we end for tonight. Thank you for joining. If you enjoyed watching me what's the word, my full skill issues on display, please do like and subscribe, and I'll see you around.